Hi everyone, Alex is here. Let's talk about WebSockets. WebSockets. So incredible, so hard, but so needed. Basically, it's modern protocol, honestly speaking, that help us to work with full duplex and permanent channel for connection with our client and server. So what does it mean? Basically, we have a good protocol, everything's incredible, but we have a problem. It just makes one request, and not like one request, but it's only one-time operation to take some data and receive back information from that, or send some information and receive back. In any case, it's only one-time operation. And what is the problem here? Every time we're just taking information, sending to get information, taking them back, and everything should be okay. But the problem is when we should every time takes the same data. We have a problem. We have a chat, and how we can make the thing that when someone is writing from one place, another one will instantly take the information from that place. Or you have, for example, a cabinet where you have a amount of videos, for example, and you're sending one video and it should be immediately be accessible from another device, even when the web pages are open at that very moment. Or, for example, you have bank system when it's crucial to update your internal wallet that is in web application. So when you will be able to send some payment, it will always know the right amount of your sum. So basically that's the thing here. And the best example here is to working with a chat. Why? So let's go a little bit to the story. So before 2008, all the web applications, they have been using pooling or long pooling system to work with that. So what does that mean? You're just making one endpoint API and just pulling that every 5 seconds to receive some new information. Will be some new information, won't be some new information. It doesn't matter. It just requests that every time. Also, there was long pooling, so basically it just holds the connection for some time and then it's closed that. And then everything's just continuing that. And in 2009, Mike Fraser and Ian Hickson, they began to work with two binding protocol for web browsers. And in 2011, WebSockets have been officially standardized as RFC 6455. So it's important that now, from that moment, it's work with all modern browsers and servers technicas, and you shouldn't use this old pooling system. So basically, how does it work? We have our WebSockets. It makes HTTP request, but client sends it with a header updated WebSocket. That server takes that and go into the protocol if it supports that. So it will send back information. It will be called 101 switching protocols. And at that moment, it calls Handshake that your client and your server will be using WebSockets and will give information to them at real time. And after that, there will be the data are going a frames. It's not like a real powerful, a full HTTP request. So it incredibly makes not so many hard requests and overhead for you working with your request, with your API. So you shouldn't just send all of that information to HTTP. And also the problem is that server receives HTTP like a different thing. So basically it can just understand that it will be DDoS, and that's a problem. That's a huge problem here. So with the WebSocket, we just can tell that your web application should use your server to receive and give back your real-time data. That's the most important thing here. So WebSocket has to have this two-way, like full duplex two-way binding system, and when information is coming to your server, it will automatically goes to your client. So basically, it just like connects like one server to your client, and when like a client is a subscriber, and your server just sends the information and just notifies the subscriber when some new information will come or not. That's why you instantly see when someone is typing, you see this skeleton for typing, or for example, when someone is sending your data, like sending data, you also see that mostly at once. That's how it works. And once more time, it was 2009, 8. It was because like HTML5 had that like problem, and it was like the solving of that. Okay, let's talk about WebSockets problem that we have. So first one is complex of scalability. So HTTP is stateless and WebSockets is stateful. So what does it mean? That each of the session, like each of the connection, saves information. And while you have millions connection, can you imagine that your server like handles that all the time? With just HTTP, it just takes the information, goes back, and that it just closed that request. But here is all the time, like you cannot just close it. Like person is looking for something for a specific time, and that's the problem. And it like we should use some additional technology. So it should be message brokers, for example, Redis or RabbitMQ, or it should be load balancers. So basically, it helps you to work with sticky sessions. For example, when your client has an internet connection and then it wants to change the internet, or internet was just failed at one moment and then it was just reconnected. So these sticky sessions will help to reconnect to the same server where you have these WebSockets. But if that server will be down, you will be in any case reconnected to the another server, and there will be another difficulties of that. The next thing, problems with backs. So firewalls, for example. So when we have, for example, Windows computers, sometimes we can have corporate firewalls that cannot support WebSockets, or even Macs. And that's why we have a solution. It was with fallback. So you just will be using long pool. So if, for example, WebSocket is not working, you'll be using long pool. But it's still, as you see, it's more difficulty to work with that. So also we don't have a system for reconnecting that. The problem here that we should use our timeouts, or mostly it will be exponential backoffs, or for example, we should also take some working with some errors that will be during that manual reconnection. So we should do that on our side. It won't be done with WebSocket on itself. So exponential backoff basically is when you're, for example, taking 1 second to reconnect, then reconnection failed. The next attempt will be in 2 seconds, then the next attempt will be in 4 seconds, then the next attempt will be in 8 seconds, the next attempt in 16 seconds, and it will be just going up until there's some crucial line for your app. And that will not be able to look like a DDoS, because when you're trying to solve this problem, it looks like DDoS, and that's why it helps not to work with that. Also, it doesn't have any built-in notification system. So basically, you just will be using JWT token or session hooks, but you won't be able to authorize, like how to say that. It's not a standard method for authorization. So notification, so please use like HTTP and you just give JWT token. But if you don't have such system for all of that notification, it won't work. You'll have a problem. So you always should just rely on JWT tokens and the session cookies. So don't try to connect notification to that WebSockets, because it will be really headache for you. And the last thing, it's more complex for creating. For example, in JavaScript, it's quite easy to send, but when we're talking about server, it's where the complex is coming from. So basically, yes, it's hard. You should think about a lot of things, but you must use that. If you have something with real-time data, you must use it, and the profit of that will be much better, because if you'll be just improving your application and you always will be relying on pooling, in any case, you'll have just a lot of the fails of HTTP. You should take a lot of different error handling, so for a long time it will be worse for you. Then right now take a little bit more time to work with WebSockets. That's the thing that you should think about. And let's look at our code. Let's discover how it can work. Okay, let's look at our code. So basically we have our favorite CLI and SRC folder, and let's start with our CLI. So firstly, what we should do, we should go to SRC folder and then initialize our just npm package, because we will be using with our node.js just to work with our servers. So we can discover it here. We just have a basic one with node server.js. And then let's go to install our WebSockets. So it's npm install WebSockets. We can use here install, but we'll be just using I. So we're just downloading that. Everything will be added. Two packages, like one package was added and two packages of audition. So it's quite less and quite effective, on speaking. And then we can start our server. We can work also here, so it doesn't really matter. Let's run that. And WebSocket server is running on WebSocket. So this one like tells that we'll be running our WebSocket. And let's go firstly to our server and let's check it out. How does it work? And let's close for now our terminal. So what we see here, first what we see, we're taking object WebSocket server from our library and we're creating a new server that will call WebSocket server that pulls with port 880. So what we're doing next, we're having a client set that is empty right now, but it will just store our unique clients, and it always should store them. So we'll have unique values of that. So we'll be able to discover whom we should send specific information. Let's go to connection. So when we connected, so our WebSocket server is connected, it's running. Firstly, we're connecting and we're adding our new client. So we're having clients and we're adding web servers. So in this case, WebSocket is our specific client, specific data for our client. Then we have some handles for our client. First one is message. We're looking to what the message was sent and whom we should send it for. How does it work? We're client, the way to have two clients, client 1, client 2. Client 1 is sending information. And when it's sending that, so in his way, it just saves that with his JavaScript, that he has sent some information. Then this information will go into the server. Server receive this message from the client that has been written that. And then our server is sending back to the second user what the first has written. So what we have here, we're decoding the message, just taking the string, what we have received, and then we're broadcasting to all other connected clients. So we're taking clients that we have. Then we're going to each client. And then what we should discover, client isn't equal to web server client. So what does it mean? That if web server clients, so we have two clients, they have two connections. So this one is not working only for one, it's working for two clients in this moment. So that's why I was talking to you that it handles this request. So it takes them. So if there will be millions of that, it will be really tough for your server. So we have this data right top here. So we have two of them, and one of them is this client that sent information. Another is that client that hasn't sent information. And we're checking instantly. So instantly, as the message was sent, we're instantly checking two clients. One client, that client isn't that has sent that. So first client doesn't work. It was checking on that, not. This client sent it information, so this client won't receive it. Okay. The another one, we're checking that client is open, so our client can be closed. at that moment. So it can be removed, for example, from our set, or it just updated the set because we can still have our client, but just say that the state of his is closed. So we're just checking that this client is open, and if it is, so we're sending to this client that isn't the client that has sent it information, and this client is still connected with us. So once more time, this client, like when someone has sent it information, two clients in our case, checking this condition. And we're checking if our client that we're taking is not the client that sent it request. So this means that we're not the client that sent it information. And then we're sending information to our client that didn't send our message, so it's our second one. If the user closes our tab, for example, with our website, he's deleted. If you have any errors, so just write in that. And when we're just starting that, we're just writing welcome to the chat. That's all, nothing too hard. Let's go to our index.html. So basically we have here some styles, we have here some sockets, we have here chat box, and we have here input and the button send. So chat box, message input, send button. What we're working on, we're creating our WebSocket. It's the classic method that we have in our JavaScript. So we're just writing that WS, so we are working with our server that is running here. So WS, it just WebSocket server is creating such URL. So then we have function append message. So it means that when we are writing message, we will just append it. So, or not, as you will see. So const message. So we're creating a div inside of, we're just creating a div. Then we put inside of this div the message, and then to the chat box. So here we're just updating this div with our new block. And then we're scrolling that to the very bottom. This means that we'll be scrolling to the very bottom. So scroll at the top, we'll be going to the scroll height. Scroll height, it's, for example, all the height of our scroll block, so it will be going to the very down. Then we're taking our connections. So as we open that, we're just writing, you have joined the chat, so it will be just our welcome message. Then we have error, we're just saying that we're disconnected from message, like if we close it. And if we have error, we're just also writing in our console log our error. And when we are receiving information, we're just writing others, so someone else, so we're not making too complex chat system, like something easy. And this event contains our data that we'll be sending. So this event has a lot of other data, you can check them to know what we are also sending. And send button, so when we are sending, we're taking the value where if message existed, we're sending it to our server, and we're append message, so we're appending in our box our message, and then we're cleans our input. How we can work with that? We're just going to our folder, to our index.html, and we're open that in Google Chrome. So we see that here. Then we can copy that to tabs here. And let's discover what we have right now in our server. So we have new client connected and new client connected. Okay. After that, let's go and let's write something. For example, hello, my name is user1. We're sending that and we're instantly have it here. Do you see other? And here is you. So it understands in the way it was written here. You. So it's just the method that we have written. You can also check the WebSocket here. Let's reconnect it. So our WebSocket, you have seen that we have switched the protocol. Messages, what do we have here at messages right now? Hello, user1. Hello, my name is user1. Length time. My name is user2. That what we sent, do you see? What we have sent. That's what we have received here. How are you? We can even try, I can even try to do this in this way. No, it won't work, one sec. We can try to go, I just can make that, like, we can just split the screen here and here. What is a useful tool? Right now, how are you? And you see it here, how it will be working instantly. And it's not pulling this data. We do not have any delay with this pulling because we can have 5 seconds delay. Here is everything is working instantly, and the server just received this information. Do you see client is disconnected, new client was connected? So we're just like, our clients are subscribers, and we're just observing them, like sending, hey, we have a new message for you, check it out. That's how it works. And I hope that you now understand better how WebSockets works. Yes, simple idea how does it should looks like, but that's what is all based on why you should use that to improve your web application. Thanks everyone for watching this video. Hope that you like that and you discover something new for you. All the best for you. Bye.